evaluate the indefinite integral. So here we have the integral dx over the square root of 1 minus x squared times the sine inverse x. Okay, so we have to decide which one are we going to use the substitution for. Well, we do know what the antiderivative of the sine inverse x is. So recall that we're going to let u equal the sine inverse of x. And the reason being is we know that if we take the derivative of both sides with respect to x, the derivative of the sine inverse of x is 1 over the square root of 1 minus x squared dx. Okay, so you can see here that we have a 1 in the numerator, and you see that we're dividing that, and then we have a dx. So it looks like we can create that substitution pretty quick. So therefore, in step number 3, let's rewrite this. So we have 1 over the sine inverse x times 1 over the square root of 1 minus x squared dx. And now we can go ahead and put in the substitution. So we know that the sine inverse x is u, so this is going to be 1 over u times the substitution, which is du. So now let's take the antiderivative of 1 over u du. And remember that we know that when we take the antiderivative of 1 over a variable with an exponent of 1, that means the antiderivative is going to be the natural log. So that means we're going to take the natural log of the absolute value of u plus c. And now, substituting what u was in the original problem is the sine inverse of x. So we're going to get the natural log of the sine inverse of x plus c.